Can you hear me okay? All right, good. Gone live. Hello, everyone. Good morning. I want to welcome you all to the Driverless AI webinar and hands-on hackathon session. Today we have an exciting speaker, and you got a ton of people signing in as well. So as we are settling in, I will give them all a few minutes to get in. A few logistics. Before we start, I'll introduce myself. My name is Vinod Iyengar. I'm the Director of Marketing here at H2O.ai. And happy to have you all in this webinar. On your GoToWebinar panel, you should see an opportunity to submit your questions in the questions tab. Please submit them throughout the session, and we'll be able to answer them at the end of the session if you have some time. We'll be going over how to set up Qwiklabs on your machine, and Arno will walk you through the steps for doing that as well. Without further ado, I'm going to hand it over to Arno Candel, the CTO of H2O.ai, who's going to do the session.
Welcome everyone to this webinar of Driverless AI. I'm Arno Candel, I'm the CTO of H2O, and I'm very delighted to tell you about Driverless AI today. This is our flagship product. It launched about 5 months or so ago, and it's an amazing product that does automatic feature engineering and data science. But just to give you a brief background of the company and of myself, the company started in 2011, 2012 to do machine learning, and that's also what I've been doing since about then. I started in 2012 with machine learning. I have a background in physics, supercomputing, and we've basically spent the last half decade on automating as much as we can in machine learning and data science so that people can be more productive. And that's what H2O has been known for in the last few years, and we've been adopted widely through our open source product H2O3, and this here is our closed source product. It's called Driverless AI, and it builds on the infrastructure and technologies that we have developed in the past few years. The team is growing. We recently announced Series C funding. We are about 86 people right now, and every day this count is changing a slight little bit. This is really an amazing team, and without their work, we wouldn't have this product here. So this is definitely a team effort. It's a maker's culture. Everybody is working. We have over 50 engineers out of those 86, where we call engineers anyone who's actually adding to the product. The work that you have to do today, if you want to follow along, is not too difficult. You just have to go to this URL, h2oai.qwiklab.com. And Qwiklab is spelled with a Q-W-I-K. And I'll show you how to do that in just a second. But it's basically a way for you to follow along using your own instance of Driverless AI. You don't have to do that. You can just watch my screen. But this will be available to you. And also in the coming days and weeks, you will be able to do the same thing. So not just right now, but in any case, if you want to do this yourself, you need a license key. And you probably got an email from us. So please check your email for a license key. If you don't have that, we can help you out a little bit later if people have problems. But still, look for your license key in your email, and also try to follow along if you can. That will definitely make your experience a little bit better. So here is qwiklab.com, and the prefix is h2oai.qwiklab. I hope everybody can get here, and then you should see Introduction to Driverless AI. If you don't see this, press again here on the catalog. You should see this option here presented to you, Introduction to Driverless AI 1 GPU. And you click on that. You should see this screen. And on this screen, there is a button called Start Lab. Do not press that yet, but you can press it in a few minutes from now. As soon as you press this, an instance will be started on Amazon that has Driverless AI on it. And as soon as that's running, we can start playing. But I will first go through some slides. So there's no point for you to start it yet because it'll last for 1 hour after you start. So you don't want to give away any of this precious time while I'm speaking. So give it a couple minutes, maybe 5 to 10 minutes before you start that button. If you don't do it, you can always do it when I start it later. It takes only a few seconds to launch, okay? If you don't have significant problems, you can probably leave some comments saying, okay, that you're ready, that you have this screen in front of you. If there's no problems, we will continue with the section of the slides. So as you all know, data scientists are in high demand right now. There's definitely not enough of them, definitely not enough of the really good ones. And if you are one of them, congratulations. If you're trying to get better, also congratulations, because this is still a very modern and new field. So if you just practice every day, you'll get better, and you will be one of those data scientists in high demand if you're not already. If you know Kaggle, that was acquired by Google. It's a competitive platform for data science, and there's only 100 or so grandmasters. And those are the world's best competitive data scientists, according to this metric of Kaggle, which is probably the #1 data science platform. And out of those 92, we currently have 4 working at H2O AI, and they have helped build this product. And there's many mistakes that people make, even the world's best. So this Andrew Ng is one of the world's most renowned data scientists or machine learning leaders, if you want, known for deep learning especially. Even they make mistakes. So they forgot to make sure that individuals are separated in training and validation, and that mistake led to some wrong accuracy in some papers that were presented about lung pneumonia detection, right? And only if you do it right, you get the correct numbers. So even the world's best make mistakes. And our goal is to automate that to avoid these mistakes. And these are not difficult changes. You just have to do no mistake to be correct. And the subtlety is here in knowing what not to do, basically. And we have been reviewed by InfoWorld 2 months ago, and we got the Editor's Choice Award, which is only given out a couple times a year or so. So this is a nice achievement of Driverless AI to be liked by the reviewers. And the secret sauce is the feature engineering. So if you know, machine learning is basically running algorithms that need to learn from data. But the data that business has is not always in a form that looks just like a simple matrix with numbers. So you have strings in there, you have dates, you have missing values, you have text fields, you have stuff that's not quite ready for the machine to take. Maybe not normalized, maybe different units, all kinds of stuff. So feature engineering is the art, basically, to turn that data into a more useful format so that the algorithm can be more productive. And algorithms like H2O3 will actually work on that raw data, but the accuracy might not be as high as if you spend some time doing this feature engineering. So even Andrew Ng himself is here cited by Wikipedia to say that it's difficult and time-consuming and it requires expert knowledge. So feature engineering is the heart of machine learning if done right. And here is a webinar that we have prepared in the past. These slides will be available later. You can find these webinars on our website as well, h2o.ai. But this is a webinar of one of the Kaggle grandmasters that has helped to build Driverless AI. So I definitely recommend you watching that. So what can Driverless AI do that you might not be able to do yourself unless you're an expert? Well, it can compete in these data science competitions. And there is a competition that was 2 years ago. It's called BNP Paribas. It had 3,000 teams competing for 2 months or so. It was a long competition. And in the end, the winners had an accuracy of 0.42, which is measured with a log loss. So less is better here. Smaller numbers is a smaller error. That log loss of 0.42 was the best number. And Driverless AI can get to a 0.43. And you see this here in the private score number here. This is Driverless AI that I submitted, and that was running on my home PC overnight. It took 6 hours or so, and it wasn't even any effort for me. I just had to click once and then wait 6 hours. And that score, that 43.3, would have been 18th on that leaderboard out of 3,000 competitors. So that's in the top 0.5% of all competitive data scientists out of the box. So we automated what grandmasters are doing, and this can save you precious time, especially if you don't have those expert data scientists. And even if you're an expert data scientist, you can actually take Driverless AI and make even more out of it. So in this example here, this is the Amazon Kaggle competition, and Marios, also known as Casanova, who was previously #1 at Kaggle, he also works for us. He has made this repository with code and also a YouTube video to explain how we can use Driverless AI and make even more out of it. And he was able to get into the 20th place on that competition after adding logistic regression with one-hot encoding on top of Driverless AI. So Driverless AI definitely can do a lot of work for you, and if you know what to do, you can do even more. Driverless AI has a key element, which is automatic visualization. So it's not just doing data science engineering and all that, but it also does some of the unsupervised parts of the work, which is to figure out if you have anomalies or not, whether you have some weird distributions, whether you have something wrong with the data, maybe some missing values in some columns that only show up for some rows, and so on. So this is done with a very modern approach that is unprecedented. This was done by the person who wrote the book, The Grammar of Graphics, which is, that person is Lee Wilkinson. He also was foundational for the company Tableau because it's built on his book. And ggplot, if you know that library, that's an R package. So all the visualization tools today are using basically the book he wrote, and he's now at H2O to drive forward this effort of automating visualization itself. And soon we'll use that knowledge to do even better data cleaning and data preparation. So it can all be automated. Another key element of Driverless AI is the machine learning interpretation. So when you have a model, you don't just want to put it in production, but you want to understand why it's making certain predictions on a row-by-row basis. So for this person, why did we predict that they would churn, or they would be fraudulent, or they would sell their home for 5 million? And you can explain that with local interpretation, which is also something that we are leading the field in. So this is a great product that combines these three pieces. And at the end of it, you can actually deploy the models, not just in Python, but also in Java or C. And the work for that is still ongoing, but I expect within a month or so, we'll have that fully working for everyone to use. So there will be a MOJO, just like in H2O3. For those who are familiar with that, this is a production pipeline that does all the feature engineering and the model predictions all in one code base, which is standalone and has no dependencies and is as fast as it gets. The architecture of Driverless AI is definitely designed to be scalable and approachable from all angles. So there's a place where you can talk to it. That's the left side here. You can either connect to it from the GUI, as we'll do in a few minutes, or through a Python console, such as a Jupyter Notebook. And then when the experiments are running, you can look at them in the GUI, you can query them from remote, you can have a client-server connection, you can deploy the models in different places, such as the client-server architecture, a one-click model deployment on cloud services. You can do this Java deployment for low latency scoring. There's also a retrain facility for larger data sets, and also data munging facilities where you can actually create the feature engineering on bigger data sets as well. And all these recipes, as we call them, the smarts inside can be programmed and are flexible. So you'll be able at some point in this year to bring your own recipes and have new insights that you want to bring to this platform as part of this production system. So with minimal changes, you will be able to customize this driverless AI. The roadmap is filled with cool features. We already have this Kaggle-winning recipes. We have interpretation, visualization. We definitely don't make mistakes like overfitting or leakage, where we are very careful that the numbers that we tell you are good estimates of the generalization performance of the models. There is already multi-GPU support. So if you have a box with 4 GPUs or 8 GPUs, you can actually do very well with that. It's much faster than on CPUs. The scoring engine is coming to Java. As I mentioned earlier, we'll have Hadoop connectors, S3, SQL connectors. We'll have user management with security and authentication. We'll have deep learning recipes that use TensorFlow, time series recipes with LSTMs. And we'll also use multi-GPU for single models. So that means one model can be so big that it needs multiple GPUs to fit. And that will then be really cool for data sets that are bigger than, say, 10 gigabytes. And you will be able to bring your own recipes. You can call them UDRs. And at some point in the future, we'll also have multi-node. So since this architecture is flexible, it isn't too difficult to distribute the work to multiple nodes. So if you have multiple DGXs, for example, these are the NVIDIA supercomputers, each with 8 GPUs, you can do a lot of harm with this system to the basic conventional approaches that are human-driven. And even further out, we'll have a sparkling water backend. And that is going to be amazing because then you'll be able to retrain the smart feature engineering pipeline on really big data on a Spark H2O sparkling water combination. And everything is on our website. You can download the product right now. I suggest you don't because you're focusing on this webinar right now, and you also are going to get the preloaded instance going in a second. So if you want, you can press the go button right now, the start button, and that should be ready in a minute or two. And if not, you can wait for me to do it. It's really not going to take too long. But you can apply to get a registration key. You can watch other webinars. You can look at the booklets and so on. So it's all online. And the hands-on lab will start now. And I think we'll have plenty of time, about half an hour or so, to do this together. And at the end, you'll have 10 minutes or so for questions. And that should be enough time. If you have a lot of questions, we can also do 15 minutes of that. So let's see how it goes. And I'll switch over to the labs now. I'll click on Start Lab. And at some moment later, we'll have an IP address here that you can just copy paste with this. You open up a new tab, you paste in that IP address, and oops, here we go. Already we have that instance running very nicely. This Qwiklabs is really useful to demo these things, and you just have to agree to these terms. So if you read them, it basically says, this is an evaluation license, and we don't guarantee for anything. So obviously, you still have to do data science. You still have to know what data you present to the system and what the consequences are if you have biases in your data that the model then learns and then makes these predictions. We can't fix human biases in data that are already present, but at least we can help you find them. So you can type any password and username. This is just to separate multiple users. So I will do H2O, H2O. And now I will save that for later. And it says, hey, give me a license file. And I have to now go get that. Now you do the same. You go to your email. You find a license key somewhere like this. You copy that. And you have to paste it right here where it says enter license at the top. And when you paste that in, it should show you something in the bottom that shows you what kind of license that is. And you can say save. and then the notification at the top should go away. Okay. If anybody has problems with this because they can't open their email, they never got an email, then we can also paste a license key for you in the GoToMeeting chat system, and you can use this license. But that will expire in a couple days, so you will have to press the X button right next to that little warning that says that your license will expire soon, if you're bothered by it. Okay, so I hope everybody can follow to this point. Now you should see H2O AI at the top with version 1014. That is the latest version, and we can add data to it. Now you could drag and drop it into this screen as well from your laptop. But what we are going to do is we're going to use a preloaded data set that's in the data folder. Data, Kaggle, and then credit card. And why this data set? Well, that's one that is easy to interpret and it's small, so it's not taking too long to run for demo purposes. I'll explain it to you later. I have a link right here that goes to Kaggle to explain that data set. But first we'll load it in and we'll start the experiment because it'll take a few minutes to run. So we have a credit card train. Okay, and then we have a test one. I already had a train one here, so I can also delete data sets, as you can see. And now you have a train and a test data set. One is 24,000 rows, one is 6,000 rows. And you can do multiple things now. One thing would be to visualize it. So you just click on it, as it says there, click for actions, and then you say visualize. And that will show you a quick visualization, automatically finds the stuff that's important about this data set. And now would be a good time to actually look at the description of the data set. So we can maybe go at the correlation graph just to get an idea, and then we'll look at the description to see what's going on. So here there are some points that are not connected, like sex and marriage. They don't matter too much. The ID doesn't matter, but bill amount matters. You see, bill amount, they're all connected. So let's look at the credit card data sets. I'll open that in a new tab. The data set is predicting whether somebody will default on their payment. And that is a Taiwanese bank. The data set is over a decade old, but it's still relevant, I think. And there are 25 variables, how much of the credit they were given, and then what their gender was, the education levels, whether they're married or not, their age. And then the important ones are here, these repayment statuses. So one says, the 0th one says, right now, as of the moment of that data set, did they pay or not in the last instance where they should have paid? Are they delayed by 1 month or 2 months or so on, 9 months? So that delayment, that delay is critical, right? You would expect pay 0 to matter a lot. And then the same is true for the previous months, all the way back to April. So pay 0 to pay 6 are just previous payment statuses. And then the same thing for bill amount and pay amounts. And this is the target column here that says yes or no, did they default or not? So this is something we can probably reasonably well interpret. So you can see the visualization here. Let's look at some outliers. There's maybe here outliers. And you see that bill amount 4 has some interesting outliers here. But bill amount 2 maybe not, right? Because it didn't show up. And pay amount 3 has something here. One point is much higher than all the others, and so on. Limit balance has an outlier. Here's another interesting one. So you can see that automatic visualization can definitely help you expose some issues in the data. So let's go back to the data set and say, instead of visualizing, we want to predict something. So let's predict a column from all the other columns. What do I want to predict? Well, whether there is going to be a default on the payment next month. And for fun, we can pass a test data set. The problem is there is no answer for this test data set because it's a Kaggle data set. So they don't give us that default next month column in that test data set. But we still can make predictions for it. And that's what will happen when we pass that test data set. Now, if there was an actual target column in there, we would actually score the final model and say how well we're doing on it, but only one time at the very end. We would never use that for parameter tuning. Okay, so the test set is purely used as a test set. It's not a parameter tuning set, as also called as validation data set. We make our own validation data set splits from the training data set. So this is purely optional. You can also drop columns if you don't like certain columns because they are not supposed to be used by the model. You can also provide fold columns to create certification folds, which means, for example, that example I mentioned earlier with the human issues about that paper that Andrew Ng was writing, that the lung pneumonia detection, you want to have separation of individuals between training and validation splits. So you should pass the individual ID as a fold column so that you don't memorize the lung shape of a certain person and say, oh, I know that that person has pneumonia just because I saw that lung shape before, right? You want to be able to predict on a new person that's unseen whether there is pneumonia or not. So you have to separate the groups of same people. Either they belong to the training split or they belong to the validation split, but you can't have the same person show up in both sides. So this is what the fold column does. It separates them. You can also provide observation weights that say how important certain rows are as opposed to others. It's just a relative importance. But now that we have this, let's turn down the time a little bit, maybe go down to 2 or so. You can look at the accuracy. If you don't know what they mean, there is actually a help button here. So if you click help, it'll open up the documentation on the web page. And that will actually tell you all about these things. And it will give you a full table, what happens at certain settings for accuracy and so on, okay? So there's always help. You don't need to worry about these things. Just click on help either here or at the top. Okay, I'll say go now. I'll launch this experiment. And now this is running on a single GPU box because that's what Qwiklabs is providing you through our automated webinar hands-on session system. And this one GPU now is starting already to pump out models. And you see here that the left side, there are some scores popping up. So this top left side will never change. That's just telling you what the data is. This in the middle here tells you how many models have been tuned so far and what's the progress. And on the right side, you'll see what the settings were. So we are now going to optimize the AUC, which is a common metric that tells you how well you're doing on a binary classification problem, such as this one here. And on the right side, on the bottom, you see the GPU and CPU usage. Now, you could say, well, this is not so fast, but you know, this is already making many models. So in red, you see data transformation steps, and in green, you see GPU models being trained. So this is one model, this is another model, there's another model, and so on. And these little red pieces are transformers. So these are filter transformers that are doing certain passing through of data, but there's also other transformers that will do target encoding, for example. And that is the feature engineering magic that gives the higher accuracy. And I'll explain some of those feature transformations in a second. You will see them show up here in the middle under the variable importance chart, which once the model comes in here with some higher accuracy, you'll see why this model is better, because it made these features. So in this case, we still are using the original pay zero feature, which is the one that tells you how that person made a payment in the most recent month, which is the feature we suspected was going to be important. So that is the most important one. But the bill amounts and the payment amounts in previous months also matter. And as soon as we have engineered some more feature engineering steps and basically made more data for that data set, then that new data will be useful as well. You can see at the top, we're still doing parameter tuning. So at this point, we're actually testing 16 different models, and we're looking at which one is performing the best. So this is a one-time tuning of the model parameters. In this case, we're using a gradient boosting machine on GPUs. And After these 16 models have been trained, as you can see in the traces here, these are the 16 models with different parameters. Some take a little longer, some are shorter. You see the parameters on the right side. Once you know which one is the best, we are making some features, even more features than on the left side here. These were just the initial features that were needed to evaluate the different parameter tuning models. But now that we know which models we're using, now we are focusing back on the feature engineering. So there's a lot of feature engineering going on here. And if you want to look into it into more detail, you can pause this. You can click on this box here and you can zoom in. And you can see, for example, this here is a cluster ID target encoding. So it will cluster the data set into cohorts, and then it will go and look at the response, in this case, the default probability in each of those clusters. And it will say, well, if you belong to this cluster, then this is the likelihood of you to default. So this is a good feature because later when a new point comes in, we can say, well, what cluster does this point belong to? And then we have already some estimate of the probability of default just from the cluster assignment. And this one here, for example, is a numeric to categorical weight of evidence transformer. So it will first take a numerical column, it will bin it into categorical buckets. So it will say, do I belong to the first decile or the second decile or the third decile, for example? And then for each of those, it will do a weight of evidence calculation, which is a ratio of default versus non-default, and then it will take the logarithm of that. That's a common technique used in credit scoring. So we automated all that, and if you go back, by now you should probably see a new model coming in, if not very shortly. That new model will most likely use these new features. So right now you still see the old features in quotes, the base features that only have replaced the categorical ones with target encoding here. This TE means target encoding, which is replace the levels like they missed the payment or they didn't miss the payment. So those categorical levels are now replaced with a numeric column that has the actual probability estimate for each of those levels. So this is a purely numeric matrix that we present to the algorithm, and these are the features that turn it into numeric. So all the categoricals are mapped to numeric features through this target encoding, and that was what was used in the very beginning for the target for the parameter tuning. But now we're still building engineering features. As soon as that's done, yes, you see here there's a lot of features generated because we're doing repeated holdouts. So we're not just splitting the data set once, but we're doing something similar to cross-validation. In this case, we're doing twofold repeated train validation splits because it's a small data set. You see this is only 24,000 rows, so it's actually very small. You can do this on millions of rows, and you'll see the accuracy. They should really be very competitive. If we, for some reason, are not very competitive, then most likely your problem is not a data set that is IID. IID means independently and individually distributed. So it's, what did I say? Independent and identically distributed. So that means every point in the data set comes from the same distribution and they don't depend on each other, right? So it's like t-shirts that you find in a big market. They're all the independent t-shirts. They're all t-shirts that come from the same distribution of all t-shirts in the world. And now you can ask it what color it has, how long the sleeves are, how many buttons it has, and so on. You can then classify the t-shirts. So that would be a good data set of attributes of t-shirts, and then the outcome is maybe the price or how much it's liked by people, for example. Now, if you have a different data set like a time series where every time you measure, let's say, the temperature in a room every minute, then the temperature at minute 600 is going to be very similar to the temperature at minute 599. that is not a data set that is independent of each other. Every row kind of matters, depends on the one before, because they're not drawn from a distribution that is where the points are independent, right? So the point is here that we have some time series capabilities in this product already, but all it does is it preserves causality. So if you detect that your dataset has time in it somehow, we'll split it based on that time. And we'll do the holdout, training, validation splits accordingly. But we're not yet creating the features based on time, such as lagging or cumulative sums and so on. So in the next month or so, you will get a version that can do much more with time series, and then you should definitely give it a try. But right now, if you have a time series problem, you can try it, but don't expect too much. So let me go back here. Okay, now it's starting with the models on top of all these smart features. So there will be something like 24 models trained before we'll see an update on the GUI. And then we should get a much more accurate model, and also one that uses those new features. Just to show you how much faster it could be if you had a faster system, here is an 8 GPU box. That 8 GPU box, I can run an experiment on the same data set. And again, I'll pass the test set just to make predictions. And I will run the same experiment. Here I can leave the time as 5 because the time really doesn't matter so much anyway. You can always stop it earlier by pressing this finish button. So time is just the amount of time you're willing to wait, and that's a relative amount. So it's basically saying default is fine when you leave it at 5, but if you have enough time, you can also run 10 and just stop it by hand once you feel like you need a model. There's no difference in the number of time, whatever you do, it's just time, basically, just the number of iterations of this genetic algorithm approach that we're using on the left. So you'll have more iterations if you have more time. The accuracy does change the number of validation splits. It does change the number of models being tried. So the accuracy definitely can make an impact to your accuracy. I usually like 7 the most, because above 7 it gets slow, but 5 is okay for most problems, but 7 is kind of the sweet spot to me if you have time, if you really care about the accuracy. Interpretability above 6 will actually start doing monotonicity constraints where the models are forced to become more interpretable. We don't yet have linear models, and we don't yet have neural nets as the main models. So those will be on the 2 extremes of interpretability very soon. You can also see there's different scorer functions that you can use. So not just AUC, but Gini or F1, or let's say the mean absolute error or the root mean squared error and so on. So you can also provide your own if you use the Python API. Contact us if you have questions regarding to that. And you see this is the 8 GPU version. This is much faster. It's already pumping out models here much faster than the other one because it also has faster CPUs. The CPUs that you got on that instance had only 4 cores. This one here probably has in the order of 30 or 60 cores. So you see all the green dots here, each one of them is a model, and each model takes about a second or so to run. So it is really fast to make models on GPUs. But let's get back to the one that we are running. It's still building models. You see the GPU is busy pumping out models. Let's see how many it has so far. So these were the first 16, and now it makes 8 more, and then we'll see something on the screen. So it'll be there very soon. Now, the kinds of feature engineering tricks that we apply are growing every week, every month, right? So if you have good ideas about how to transform, let's say, the date, or how to transform certain categorical features, high cardinality features, these would be recipes, and we're always we're always listening to our customers. So if you have suggestions, please let us know. But soon you'll be able to make your own recipes if you have confidential information you want to use. And oh, here we go. So now we have seen that the weight of evidence transformation of pay0 is actually even better than pay0 itself, because the weight of evidence log odds ratio trick is actually a good one, okay? And you can also see that, for example, clustering people by pay, how much they paid in the past, is a good idea. And inside of that cluster, to find their mean response, their mean payments, whether they default or not, I mean, that is a good indicator of future outcome. And the bill amount divided by the pay is also something that tells you basically how much they paid, how much was that out of the total bill amount. So it makes some of these interactions. It also has marriage, pay, and sex in there, which you could say is not fair, but that's the data, right? The data has that information, and this will expose it. The model said it doesn't matter whether you're married or not, and whether you're male or female. And now it's up to you to now make a interpretation of that model. And you see other features such as the numeric to categorical encoding, where it first buckets it into 25 bins, and then it does the means in each of those 25 bins. So this is pretty cool. It's just running, but if you go back to the faster version, see it's already here, and you see it flatline for a little bit, and soon it will probably jump up because it finds something better. It does this genetic approach where it tries different mutations of the transformers, and at some point it will find something better and it will pop up. If it doesn't find anything better, then you probably have done a good job already in providing your features, and there's just nothing you can do with that data set. So it doesn't always have to go up a lot. It really depends on the data. In some cases, we've seen this be better than entire teams that spend lots and lots of time on building models. And in other cases, we've seen almost no difference because the data is already there. It's like seeing trees in a forest. If you're right there and there's one tree, then there's nothing to miss. But if you're far away and you wonder where is the person in the forest, then you need an infrared camera to see that person, right? And we can basically make that infrared camera for you if there is a need for one. But if it's daylight and you have only one tree and one person, then there's nothing for you to have to look more carefully. So it's really about the data. There's nothing we can say other than it depends. Also, whether this will go up or not later, you never know. So in iteration 20, it could go up a lot, or it could never go up again. And there's also no guarantee for that, because this is not a simple convex optimization where you know that you've reached the global optimum. This is something where you never know where you're at, and you never know how much better it will be. But you know that this tool is trying basically its hardest, and it's using the smarts of data scientists that have won Kaggle competitions over and over. So if this doesn't beat you, then you're doing a good job. If it does beat you, then you know where you should focus your time. And maybe then you can start thinking about the bigger picture, which is what new features do you want to give it? What other problems do you want to solve, and so on. So this is not a competition to the data scientist. It's a tool that the data scientist should use to become more productive and to worry less about tuning and stacking, but worry more about the actual business outcome. So at any point in time, you can press the finish button, and then it will go over to the final model. And we'll soon get to the question and answer period, but I want to show you quickly a interpretation of this model. So you can press finish at any point in time, and it will go to the final scoring pipeline, which consists of a stacked ensemble as long as you're above accuracy 5 and more. So 5 itself also will do an ensemble. It actually uses 8 models inside that will be stacked. So this takes a couple more iterations here, and then you should be done. And every time it finishes, it also builds the deployment package that you can take to production. And you can just download that package and execute a little bash script on your computer. And it doesn't have to be the same computer that ran the experiment. It just needs to be a Linux box that has Python. One thing I want to also mention is the ability to start this again. So you can actually persist your experiments. If you kill this instance and you start a new, and your data sits on a shared directory, which that we recommend people do, then your data will actually, and your experiments will all be saved. So if you follow the instructions online, you can kill and restart the system, and your experiments will be saved. All your data will be there. You can look at everything. So here you can fit. You can score, predict on another data set. You can also transform data. If you want to transform data to see the munched features, those special features, you just provide a training and validation data set, and optionally also a test data set, and those 3 data sets then will get transformed into the new representation. But then you have to fit a model on it. So it's really just optional for you to get more insights. You can also visualize those if you want with automatic visualization to see how they look. You can download the holdout predictions to see what we think on the training data without overfitting. This is basically the model's predictions on the training data. And so you could use this to make observation weights, for example, and then pass it back in. You can download the test predictions. You can get the logs. You can download the scoring pipeline. All these things will take more time to explain, but they're all there. You can also interpret the model, which is what we're going to do right now. And for that, there's an entire booklet written about it. There's a whole webinar. There's a whole YouTube video of H2O World. So I can never give it full justice here, but I just want to show you how it would look like if you open it. And basically, it'll be self-explanatory. Everything has a help button next to it. Everything has a explain this. So you shouldn't have any difficulty following this. But it basically shows you the predictions of the model and compares that to the actual predictions. And for every point here, you can actually click on it and you'll see a local explanation of, for this person, why this decision was made, which were the features that mattered, and also what would have happened had some value changed. You get partial dependence. You can even get English explanations that tell you, for this person, what happened, like why did the probability go up by 0.34 because of pay 0, right? Because it had value 2, which means you were delayed. You were 2 months late, and that's why your probability of default went up. So I think we can now go over to the question and answer section.
Sure, thanks, Arno. So we have a few questions in the chat window. We'll try to get to most of them with time permitting. So the first question is, Arno, what is the best way to use Driverless AI for the average data scientist?
That's a great question. The best way to use it is actually to just get a box either on the cloud or locally and run it through your data sets that you already know. So you should use it on something that is familiar to you, some data set that is not super complicated, not super big, maybe a few 100,000 rows, maybe a few 100 columns, and just see how it does. And then maybe you can even take something even smaller and play with it and see whether this MLI makes sense to you. And then you should maybe try it maybe on 1 or 2 other data sets. You should get an idea of basically how it performs. And once you get either the respect for it or you have critical remarks, then either let us know, because what we really want is feedback. So the most important thing you can do right now is help shape the product so that it will become more useful to you. But if you're already using it and it gives you good results, then that's really what you should be doing. You should just use it to get good results and then put this model in production, because this system will allow you to do just that. And I will show you that in a second. When the model is done, you can download the scoring pipeline. And this scoring pipeline contains everything you need to put this model in production. And that is what you can then give to your IT department or put in the cloud and host a service. And soon we'll make that even easier for you through a single deployment model. But for now, you have to do something yourself. So this is currently the content of this package. And you can see there is a README that explains everything, and there will be a little example Python script that will run. And this example script, oops, I probably need to show you how to see this. Here we go. This script is very simple. All it does is import the package that we export as a wheel, and it imports a scorer, it instantiates this, and then it can make predictions on a given row or on a given data set. So I would say do the whole spiel, run it from start to end. That's how you should use it. Get used to it, and then give us feedback.
All right, thank you, Arno, for the wonderful webinar. So let's go ahead. I think there's a bunch of questions. We still have about 10 minutes, so try to take as many questions as we can. So the first question here, and actually I think something we both can take, is what is the pricing for Driverless AI? So let me take that. So we have some really exciting pricing options. We have at an entry level, you can start up at a per seat pricing for certain modules, and then upgrade from there on. For larger enterprises, we also have the option to bundle up multiple modules together and buy multiple seat licenses together. So definitely hit us up at sales@h2o.ai. I'll repeat, sales@h2o.ai. And one of our account executives will be happy to hop on a call to learn more about pricing, tell you more about pricing options. The next question here for Arno, what's the right way for an average data scientist to use Driverless? How can an average data scientist benefit from this?
Yes, I think that was just asked earlier, but it's important that you play with it. And even if you have a time series problem, you should try it and give us feedback. I think the key is really for you to push the buttons everywhere. You try different loss functions and see how it can surprise you, because we've seen people, literally their chins fell down to the floor when they saw the performance, right? And it would be significant uplifts. So be bold, try something, and let us know if it doesn't work. We will always make it better. That's our job.
The next question here, how do you ensure that the feature engineering is selecting or creating the right features to explain to the domain or business users?
Yes, so some of those features don't always look very businessy, right? You can say, why does it, let's say, for example, it could say something like age times limit balance or something. It doesn't do it right now, but it could. There's nobody that prevents that from happening. So what we do here is we present a matrix to the algorithm, and it picks up certain things, and then the feature engineering acts based on the feedback from the models and combines features. And as long as it's logically possible to combine numeric or categorical columns, we will do that. So we currently don't yet have a mechanism to prevent certain combinations from happening. So if the domain knowledge is there to say you can never ever combine age with money, for example, then these constraints should be enforceable, and we are working on adding those, but it's not currently available. So sometimes the business insights actually can improve the models where it doesn't look like it's improving, but actually it would, because in test time, in actual production, there's no way that this could ever help. But the model might not know that. So we are aware of certain things like that, but in general, this machine will give you a pretty good model, and I think there's many models that are equally good. So if you see one that you don't really understand, you can run it again, and it might look slightly differently. Unless you press the reproducible button here, it will never actually be the same. Only if you press that button, every run will be the same, but then you'll just get one instance of the outcome, which I personally don't like as much. I'd rather see it run several times, and then I'll look at the common insights. So that is definitely an unsolved problem, how to turn that into a business insight. But it's much better than having a neural net that said I multiplied 1 million times to get here, right? At least you see that this is a interaction of marriage, pay, and sex that mattered.
This is a good question, I guess. So I said for 24,000 rows, it seems to take a reasonably long time. What happens when you're running 1 million rows or more?
Yes. That's a very good question. We actually don't like small data sets for that reason, because we don't have yet a small data recipe. So what we are doing is we are doing this in Python. We developed the whole product in Python, and every single parallelization effort here is going through sub-processes that have to shuffle files around and so on. So it's not very easy in Python to do that. And Java or C++ would be much faster, but it wouldn't be faster for development. So we took the route of faster productivity to do whatever it takes, whatever model it takes, whatever feature engineering logic it takes. And we actually have data table in there, which is the fastest data munging system in R. And now we are building a Python version of data table. So we are accelerating those things greatly, but still at this point, small data is actually slower almost than big data, because the GPUs are so fast at building these models. The only thing that's slow right now is the overhead. And for small data, that overhead is basically the only thing left. For big data, the overhead is the same as for small data, so it won't show up as much. So definitely use hundreds and thousands of rows, not just 10,000 rows.
The next question here, is there any pre-processing done during training, like one-hot encoding, log transformation, min-max scaling?
Yes, definitely. That's exactly what we're doing. We're doing a lot more than just that. We're doing the log transformation of the response. For example, we have 8 other transformations we can use for regression problems. Every single time anything is read in those traces, we're doing transformations of features. So every single step here, there's new features generated and then tried by these models that are coming after that. And all these red transformations of the left side are cached. So any of these models on the right can use any of the red stuff on the left. So this is definitely our forte here, building lots and lots of feature engineering.
Cool. Next question, I guess you might have covered this, but again, I know for time series data, how do you do cross-validation while preserving the order of observations? Have you implemented methods like walk-forward validation and rolling window?
Yes, rolling window and walk-forward, that's exactly right. So we are not doing cross-validation, but we're doing multiple validation windows for time series where we preserve causality. But soon we'll have actually even more than that. Just the splits alone are not enough. We also want to make features based on time. And that's what's coming up soon. And actually the X#1 Kaggle Grandmaster Marius is working on that very problem. So we're very excited to bring that to the market very soon.
Cool. I guess, again, we should answer this question. How can I get a temp license to test this in my lab? If you go to h2o.ai.
Yes, you can go to the website. You go to the download button here.
Yeah, or even the,
and Driverless,
download.
Don't have a license key, sign up here. Here we go, boom. And
Right.
you type in information, you sign up, you get an email with the license key, and that will be good for 28 days. You can play on your own systems or on this Qwiklabs system. Qwiklabs is not very fast, so I recommend definitely getting a faster instance on Amazon or other cloud vendors, and then also getting your own hardware. And we do recommend NVIDIA GPUs that really help a lot.
So on time for one last question. Can I do driverless operations using a Java API bindings instead of Python? Essentially, how can I embed in a Java application? I guess it's kind of a roadmap question too for us.
Yes, that's a great one. It shouldn't be too hard to add, but we don't have it right now. Right now, the only client-server connection you have to do the remote controlling is through Python. But it's only a handful of requests, so it could be possible to do that through Java. So please contact us if you have strict requirements to do that. But another thing, of course, you could do is somehow make a wrapped box around some Python script and then just call that from Java as a system command or something. It doesn't have to be all controlled from Java usually. But if you do need to control everything from Java, please let us know. That's good feedback.
Perfect. Now there's a bunch of more questions. Arno and the team will try to answer those over email or via chat, but we are out of time today. Thank you all for joining the webinar. Hopefully this was extremely productive and instructive. Hopefully you guys all got a chance to play around with the product. Again, as Arno said, I recommend you all to go to the website and download the trial, get the license and play on your own instance, get your own, you can do it on the cloud as well. We have a bunch of cloud options. If you go to the documentation page, you can see all the different options for trying out Driverless. Thank you all. Thank you, Arno, for the webinar, and we'll all see you next time.